This is Learning Assessment Problem 1010. The problem-solving strategy here is that of circuits containing ideal transformers. We are asked to determine a voltage V sub O in the network from Learning Assessment Problem 10.9. We've reproduced that problem circuit here, and we'll label some quantities in the circuit. We're going to label a current I1, which is indicated here, and then we have another current. We'll choose I2 flowing in this direction. Notice that I1 enters the dotted end of the transformer winding, and I2 enters the undotted end of the secondary or the V2 winding. This transformer is indicated as having a turns ratio N equal to 2, and we'll now proceed to analyze and solve the problem to determine the current I2 so that we can predict the voltage V sub O across that 2 ohm resistor. For the current directions indicated, we'll have this principle that the turns ratio on the V1 side of the transformer times the current I1 is equal to the turns ratio on the V2 side or secondary side of the transformer times the current I2. We can solve this relationship for I2 equal to I1 divided by N2 divided by N1, and that is just the lowercase n value that we indicated on the circuit above. And that will be equal to the current I1 divided by 2 for the problem that we've been referred to. From the learning assessment problem E10.9, we had the result that I1 was equal to 3.07 at an angle of 39.81 degrees amperes. The relationship which we'll use now to determine VO is Ohm's law. That is, this V sub O is equal to 2 ohms times I2. But we've determined that is going to be 2 ohms times this current I1 divided by 2. And this will be equal to 2 ohms times 3.07 at an angle of 39.81 degrees amperes divided by that turns ratio of 2. Those cancel conveniently, and we have the result that the voltage V sub O is equal to 3.07 at the angle of 39.81 degrees volts.